Once again, welcome to the webinar, everyone. Today we're talking about molasses and straw, ammonization or anhydrous, and liquid protein supplements with Murray Feist. My name is Alicia Sapatic. I'll be chairing the webinar today. I'm the Livestock and Feed Extension Specialist based out of the Tisdale office. This session is being recorded and will be made available following the live presentation. It'll take approximately 3/4 of an hour or so, and there's lots of time for questions, which you can type into the question or chat box in your control panel there. We'll be sure to handle them throughout the presentation or via email afterwards. If you're having any difficulties with sound or would like the presenter to slow down, you can communicate that through the question box as well. And if you happen to have that closed, there is an orange arrow on the top of the control panel that'll bring it back into view for you. A survey will also appear at the end of the webinar, so please take the time to fill that out as it helps us plan future events. And with that, Murray here is our presenter. Murray is the Provincial Livestock Specialist working specifically with feeds with our livestock branch within the Ministry of Agriculture. Previously, he was a Livestock and Feed Extension Specialist with out of the Moose Jaw office or the Agriculture Knowledge Center for several years. So with all of his wisdom to share with us today, I'll turn it over to you, Murray.
Okay, thanks, Alicia. Just working through this technology, turning my cameras on, so hopefully, unfortunately, some of you will get to see me now again. Yeah, thank you for that, and appreciate it. And hopefully those of you who are with the new technology, if you're sitting on the tractor trying to watch this video, I don't know, at 35-mile-an-hour baling, I guess we'll see how that works out, so don't hit the ditch or anything crazy like that. I'm going to turn off my one camera here and we'll just jump into slides. Alicia, can you confirm that you see my title slide still?
Yes, we can.
Okay, great. So technology does seem to be in our favor today, and we'll just roll it out from there. So thanks for the introduction again. And I guess I've been asked to talk about anhydrous and molasses for low quality forages. And so, I mean, it's a pretty popular topic. I will say, I mean, if anybody is interested in this and they've got a bit of a handle on Google or web searching, I mean, there's a lot of information on the internet right now from reputable sources on how to manage anhydrous, how to manage molasses. The representatives that sell some of these products, I mean, they're very, very good people that know what they're doing with this. So, you know, there's a lot of information out there. My goal here is we'll just talk a bit about that in the Saskatchewan application. We have a bit of a different year ahead of us coming through, and so forth. And what I struggled with in these talks is usually, you know, with an audience in person, you can tell whether you're hitting the mark or somebody's falling asleep, or if the slides are too complicated or too much text on there. I went down the road of putting more text on these slides because this is being recorded. So I thought it would be easy to have it that it's readable later. So we won't show War and Peace, but there'll be a little more text than what I would normally have, or maybe I think I normally have. So we'll just get onto the slide and see what we got. I guess at the end of the day, what we're trying to do is just balance a diet, regardless of the feed we're using. And you know, this year we're seeing a lot of different questions and uses for different feeds, from kochia to you know, where can I apply this kind of a hay, how much grain, what kind of grain, and you know, at the end of the day, we got to start with these three main goals, and essentially is, what do you need to know? You need to know what feed you have and what's its nutrient content, and then secondly, what is the animal's requirement, and then how do you meet those two? But then in the mix of all this is sort of where the caveats kick in, and what are the limitations that we're dealing with? Is it fiber? Is it, you know, are we going to have a mineral deficiency or toxicity? You know, how are we set up for vitamins? How are we set up for energy or protein? And so, you know, once we know what's in our feed, and once we know what our goals of production are, from the dry cow to the weaned calf to a feeder animal, you know, once we know what we're chasing after, we can start applying some of these other concepts of limitations and balancing. In particular for today, you know, forage quality and straw rations, I think that's sort of the topic that we're interested in, especially moving forward in you know, the availability of feed that we have. And you know, straw is the one big question mark that we have. Green feed is another. But you know, an application of this, straw is the lowest quality forage we typically would feed to cattle or ruminants. And so that's not really any surprise. We have a characteristic of a feed that is high in fiber, low in protein, considerably low in digestibility, low in energy, and low in minerals and vitamins. And we can pretty much say low in comparison to your standard hay sample, whether it's a brome grass or something to that effect. And there's varying degrees within that title. I think it would be fairly acceptable to say that most hay diets straw rations that we have and straw diets, we will require some supplementation at some point or another. And we can't just use straw alone. That just doesn't go very far. So what are the considerations then, and in terms of its most basic features? Straw-based diets, because it's such a low digestible feed, the rule of thumb is 1.25 to 1.4% of body weight is maximum intake. And for a relatively average cow size of 1,400 pounds per cow, what we're looking at is anywhere from 17.5 to 20 pounds of straw per head per day. And that's pretty much a consistent number. That's a rule of thumb you can find. And I think that number is very important, because if you process that straw bale, or you feed it whole or long stem versions, the goal is to try and prevent impaction and maximize intake. So we try and use that as a low priced option normally. And this year that may not be considered low priced, but I mean, it is considered that, for the price and as a filler feed, that's sort of the maximum amount, which we would have to add supplementation to. The question about canola straw, I mean, there's lots of caveats with that. The sulfur content, we've got lots of regrowth and greenery, and how green is a straw. So the definition of straw is important in this case. The greener the straw, we do have, some considerations with sulfur in the past, looking at sulfur content. What about high sulfate water, the combination of the two, and all those checks and balances? And I think by now there's been a lot of extension and a lot of discussion around, testing water and testing your rations. I think the key when we're dealing with this is, if in a year like this, where we may have limited forage availability, we want to monitor body condition score when we're on straw diets. And that's pretty important, because any slippage on body condition score that we are observing, that has long-term ramifications. We may be stressed for feed supplies now, but the wrong kind of diet down the road can impact colostrum quality, can impact calf health, birth weights, you name it. So we want to monitor all those sorts of things, and health effects, especially that come with low nutritional contents, minerals and vitamins included. Now here's a table that I put in here, just because there's different feeds that we grow on the prairies, and the type of straws that we would have available to us. And a lot of times the questions come in, well, what makes cereal straw different from a flax straw or a lentil straw and canola straw? And if we go back to the version of what makes a straw and what makes them different, most of the differences come in the form of the protein content. And again, I mean, this is mature byproduct of harvest. The level of greenness of straws will change a lot of this, but essentially, we're looking at this protein column of anywhere from 3 to 8%, typically with pulse straws having a bit of a higher percentage of protein as a characteristic inherent to the plant. Compare that to slough hay. You've got 3 to 8% here. Slough hay is consistent in that 7 to 8%, and grass alfalfa puts at 12 to 14%. To bear in mind, I mean, if you're targeting an 8% diet, you're still seeing where some of these straws are going to struggle to get to that level. TDN content, which is a total digestible nutrient value, how much of that is energy available to the animal through digestion of fiber and the sugars in the plant, and really, it's not very high. It's not a very digestible plant, and we don't see a lot of feed value that would meet requirements of even a dry cow. At the best of times, we might approach 50%, but that's not a guarantee. And law of averages would say we've got, on any given day, a plus or minus around that. Again, comparatively speaking, slough hay and your grass alfalfa hay, quite a bit higher. And we know that through experience, you can winter dry cows on these kind of feeds the energy does seem to be manageable. Where these energy values would come into play is if we wind up into -30 weather with a wind chill and we have to supplement, and that's again going back to monitoring condition score, as animals will lose condition quickly if they just have a prominently straw diet and nothing else. The last thing is that this NDF level, NDF is neutral detergent fiber. It's a bit of an indicator as to what the total fiber of the plant is. And realistically, you get into these high 70s and 80s, mid 60s in there, relative, comparing that to some other hays, and it's quite a bit higher. So it's a very fibrous feed. Again, not a lot of nutrition there, and is required to be supplemented. And where does it fall in terms of predictable intake for animals? And again, this comes back to gut fill and time of transit through the rumen. Silage, this is approximate dry matter digestibility is what that would stand for. And the silage is pretty digestible stuff. Not only is it wet, but your silage digestibility is in that 60 to 65% range. You've got a very high intake, even up to 3.5% of body weight. So in terms of pounds per day, it's fairly high, and this is in a dry number here. Excellent quality. Hey, you can get into 65, 60, and 55, and we start to see the percentage of body weight drop as we drop in quality, but we're still dealing with some pretty decent intakes in the excellent to very good quality hay category. Medium quality hay, we start to see a higher level of fiber component creep into the quality parameters. And we see our pounds per day starting to decline. Again, gut fill and time it takes to transfer the feed through the rumen with microbial activity to break down all the fibers and break it down to a point where it will pass. It just takes longer, and as it takes longer than daily intake, it drops down quite a bit. Once we start talking into the straws here, poor quality hay and some of the straws, dry matter digestibility isn't that great. A third to less than half percentage. So that's not that great. And this is where this rule of thumb really does start to play out. 1 to 1.5% of body weight as you get these low quality feeds. I don't have tree bark on here, but I mean, it's definitely, probably less than wheat straw at some point if it's just the way it is. Here's our pounds per day intake, and that doesn't look very good, especially for a 1,400 pound dry cow with no productive requirements. As we enter third and lactation type parameters, you can see that this cow is not going to be able to meet much of her nutrient requirements. The same could be said for a growing calf or a feeder animal. I mean, we can do things with straw, but there are limitations. Now, fortunately, one of the things you can do for a quick reference is you can go into our website and find the beef cow rations and winter feeding guidelines. And that just has a few sample rations. I think there's about 7 per type of forage base. And, it's a pretty good resource, frankly, to carry through and look at examples of how diets can be formulated. And one of the things that you would pick up on, especially, and this picture here comes out of the straw rations, mostly a cereal straw for that matter, is that we've seen that 20 pounds of intake for this cow, this 1,400 pound cow, mid-pregnancy, no wind, she's 6 months pregnant, 20 pounds maximum straw. And what jumps out, if you did the comparison, is that there's grain incorporated into the diet with some protein supplements, but about 9 or 8 pounds of grain, a little bit of protein, or 10 pounds of screenings, or pelleted feed. And so really what it says is that to meet the intake of that animal, we still need to get some level of protein and some level of energy brought into the diet to meet a straw diet. And I believe Dwayne Summick did a great job of this, talking about just the applications of straw and then some of the other parameters with it. If you're looking for some examples, don't hesitate to go look at this recipe book, because I think it has some very valuable information, and it's quite thorough in terms of what you would have to consider before, when building these diets. So that sets the stage for just the straw, because that basis, I think, is it's important to have, and it's good to discuss this at this level, because when we talk about how do we doctor these feeds with different applications and different treatments, what is it we're trying to achieve, and then how effective is that? And of course, then we try and have to apply some costs into this. So the basis is set. This is, we're looking at having straw as feed, but what happens when we treat it? And the two treatments that I've been asked to speak to is anhydrous ammonia, or NH3 in short, and or ammoniation, ammonization, whatever definition you're looking for, and the molasses stuff. So to start with, we'll talk about anhydrous ammonia. And the application of this chemical, the goal is mainly to improve the protein content, some of the energy, improve digestion, improve intake, try and stop heating if you've got wet bales, and stop mold growth in that case. And it has been utilized to deactivate weed seeds. So it has a variety of factors that occur when you do an anhydrous treatment. And so it does work quite effectively at doing some of these things, and not so effective at others, or at least with some limitations. What is the application rate of this product? Well, you're looking at applying anhydrous at about 3 to 3.5% of forage dry matter if your forage base is a straw, or if it's chaff piles, or if it's hulls. In this case, oat hulls is some of the work that was done at the university in Saskatoon. And then you can also apply it to hay. If hay has been baled up and wrapped, and I remember several years ago where it was wrapped up with snow on top, heating was starting to occur. You can inject the bales individually with 1.5 to 2% of the forage dry matter. You can inject the anhydrous to stop heating. Now, the one thing about anhydrous ammonia, and we'll come back to this later on, but it is a toxic gas. It's regulated under the Transportation of Dangerous Goods. It is a toxic chemical to work with, and you definitely need to treat it with a lot of healthy respect. Otherwise, things can go sideways fast and go wrong. So just what is the process? Let's say you find some product to apply it to, some straw, and you have some ammonia anhydrous to use. Well, what is the process? Well, you collect and pile your product, and you need to have it at 15 to 20% moisture. So there may be a requirement, and we've seen this with chaff, to add water if necessary. And the caveat is, if you're adding water, you need to try and make sure it's as distributed through the pile or through the bales as best as possible, because anhydrous does have an affinity for water. The goal is to make sure to get as much consistency throughout the stack or the pile as possible, so that the anhydrous will spread out evenly. You need to cover this with plastic. When applied, it will become a very gaseous form, and you don't want any of that to escape, so that the anhydrous will go in, sort out or seek out the moisture, and what it does is it disrupts the fibers of the plant or the hull, and basically frees up. It blows up some of the indigestible fibers and frees that up as a form of energy. Plus, in its true form, as a nitrogen form, it adds nitrogen to the final end product. The trick to this is once it's covered and the application has been made, let it rest for 21 days. And then after that, you have to uncover the stack and let it gas off. You can't just treat this like silage bales where you just unwrap the plastic and go feed. You should uncover and let it gas off for 2 to 3 days, because the residual anhydrous is a toxic form if fed at high levels to ruminants. So we do need to let that gas off, which does create another safety period of time during the process to be aware of. So how much does this cost, and how much anhydrous are we actually looking at utilizing? And so I tried to stay consistent with the examples that you can find off of our website. In this case, 25 straw bales that weigh 800 pounds apiece. And if you were fortunate to have them at 17% moisture already, they're 83% dry matter. And we're looking at maybe making an application of anhydrous at 3.5% of its weight. So how do, it's just a straightforward calculation. If we have 25 bales that weigh 800 pounds apiece, and we know that there's 83% dry matter, it's 25 by 800 by 83%. Those 25 bales total about 16,600 pounds of dry material. At 3.5% application rate, we would need to apply at some metered connection, either by weight or by volume, 581 pounds equivalent to that stack. So for 25 bales, we need 581 pounds. The last market report I had about a month ago, and it could have changed since then, but roughly at 1,050 a ton, that's 48 cents per pound for the anhydrous. So 581 pounds at 48 cents a pound is $276 for per 25 bales for application rate. If we then try and figure out what this means on a per bale or per pound basis, you know, to back this out, $276 for those bales, we go back to the 25 bales. So 25 bales at 800 pounds weighs 20,000 pounds of straw as fed. That's 0.0138 or 0.014 cents per pound on the straw. You can follow the math with that, but really it works out to $11 per bale or $30 a ton additional cost when you make that anhydrous application. So I'm taking a little bit of time to walk through this step by step because I think that's important to realize that when we make this application of anhydrous on these forages, you know, it's an additional $30 a ton that we're looking at in terms of final value. Now, I stopped here. I've included the cost of covering because I could find a price on my local PV Mart webpage that silage plastic, 6 mil black poly 4x100 at that time was $250. And since you're buying the plastic anyways, you know, your $250, divide that by 20,000 pounds of straw. So this is your covering cost. It's an additional cent a pound or 1.25 cents a pound by costing it out, which doesn't seem like much until when you add it up, that's an additional $10 a bale or $27.55 a ton. So if someone in fact checks my math on that, I think I'm pretty right on that. My calculator isn't that hinky and glitchy, but yeah, that's the numbers that I came up with. And it kind of actually surprised me a little bit myself just to see what that worked out to. So what does that mean? And in terms of the benefits, because we talk about the benefits of using anhydrous, and I should go back and say, you know, anhydrous was popular about 20 years ago because it did have these effects and it worked out really well. When asking why it started to drop out of popularity, it's because we had good crops. Hay quality was actually better than it has been, even though these benefits were there and you know, availability wasn't an issue, but we'll come back to that. The benefits then of using ammoniation or applying this, if our base straw, barley straw, is 4.5% crude protein, you know, treating it based on research terms, we get to 80.3%. So we've improved our crude protein by 84%. Notice that we're still not reaching grass hay equivalency, okay? Total digestible nutrients as a percentage of dry matter, if we start at 42% or less, you know, we can get up to 48. That's that 15% increase in energy just based on the disruption of fibers and release of some digestible tissues. And you know, this 48 still doesn't get us to grass hay quality. Now, if your starting point is a lot higher, you might get to this, but we're dealing with a straw, which may not get us there. So this is the importance of why a feed test would be crucial to get to that point. We know that the intake limits for a 1,400 pound dry cow based on the previous numbers was 20 pounds per head per day. Now, the research has shown that you can improve intake levels by up to 15 to 30%. So if you use that kind of a value in between, 20 pounds at about 17%, I think I used, 20, I think was 23 pounds. You know, we're still, even if we jumped it up as the full throttle, you know, we're still not quite at 42 pounds or 35 pounds. So we're getting there, but we still have this limitation. It doesn't actually get us to where we can consume, the cow can consume this to the same degree as what a grass hay would provide. If our base price of barley straw is $100 a ton, when I added up just the anhydrous and the plastic for covering, it's $157. If we include the labor and time that goes involved with this, or additional minerals and vitamins and yardage costs, you know, our base cost is $100. You know, we're already 157, and we haven't even paid ourselves yet. That's a 57% increase in cost. You know, 157, we're still cheaper than a grass hay. I kind of just lumped all of the latest survey numbers into one number. So that's a dog's breakfast of quality. But you know, we're still even using that number, and you can dispute that. That's what we've got. Cost per pound is, you know, 4.5 cents a pound versus 7 cents a pound. Again, this is you know, I've got this variability in here because I haven't included baling costs or any others. This is just simply a 57% base cost increase. It can go up to 65%, pick a number. You know, hay, we're still at 8 cents a pound. So we have come up, and what I think I got out of this is that we've got better, we've got an increase in protein, good for us, good, bounce in TDN, but not so great. We didn't gain much on our intake, but we sure brought our costs up to that of a hay. So we're, it's an expensive hay is really what we've come back to. And it's a 19% increase in straw feed cost for every pound of intake. So, this $57 to get 3 pounds of intake in this example, that's about a $19 per pound increase if you use that as a ratio. Whether that's valid or not, I mean, I just found that, you can read statistics any way you want. So that's what I'm getting from that angle. Again, the economic summary, I broke it down a different way. If you're in hydrous at $1,050 a ton, it works out to 48 cents a pound. An additional $30 a ton is if you use the application on a straw or a chaff. And for each 800-pound bale, it's an additional $11. Your plastic at $250 for that 4,000 square foot silage plastic. It's based on the math I did, it was 6 cents a pound. $27.55 additional cost per ton, so another $10 a bale. You're increasing your cost by 54 cents per pound, or $57 a ton, close to $60 a ton additional cost to make this work, which is another $21 per straw bale. So I bring this in this format just so that, if we're considering this as an application treatment, these are the costs that are pretty rough bar napkin style math. And what does that work out to in terms of, can we feed this to animals? Can we get enough return? Does it pay to do this? And so that's the information I'm presenting to you in terms of how I approach this topic for today. And none of this really matters until we start doing a ration comparison, I guess. And so I used the cow bites program to do a very generic, I guess I hit it with a hammer approach and nothing too complicated. But for a 1,400-pound cow, and we wanted to put half a pound a day average daily gain on her, and we still haven't balanced for minerals and vitamins, but, a hay diet. 28 pounds of hay would just maintain her nicely if it's of good quality. I think this is a better quality hay than I'm giving it credit for, but 57%, this is like good stuff that hasn't seen a lick of anything on it. We're marginally feeding 1.8% of body weight to maintain a dry cow weight, early gestation, 10% protein, 57. To gain a half a body condition score, 70 pounds, would take 135 days on a feed like this. So based on this brome hay at $175 a ton, price per head per day is $2.22 just for that feed alone. So to gain 70 pounds, over 135 days, it's $300. If we try and do this with straw, based on the diets that we had in the ration guide or in the cow bites, I kind of marginally said, well, I'll try and keep it as close as I can. I didn't want to spend a ton of money fine tuning the axe on this, but straw at $100 a ton, 18.5 pounds of straw and 9 pounds of barley before minerals and vitamins. We're at same intake, so approximately same dry matter intake as a percentage of body weight. TDN is a couple of units lower. You see the difference here is in the protein. The grams of protein, or the percentage of protein in the diet, is quite a bit less, and 4 units less. And it takes 290 days then for an estimated ability, and she's obviously not going to be gaining that well then. Your diet is a little more expensive. Again, thank you to the fantastic grain prices that are out there right now that are shafting it. And at 229, it takes that long, 290 days at a higher cost. We're at 664. So does it pay then to apply some anhydrous and put that extra $57 a ton roughly onto the feed to gain a marginal increase? So if we do balance it, and this is a little bit of work to try and get to that half a pound a day, would be 21 pounds of straw with considerably less barley, and total intake again similar to what we had before. 1.75% of body weight. TDN is marginally better, but here we see 9.4% protein. So this is the benefit that the anhydrous brought. It brought us marginal increase in TDN, marginal increase in intake, but really a good increase in protein. And what that did was it kind of hit the middle ground of 220 days now to gain 70 pounds. And so it's the most expensive diet. because we've now added grain and a higher price straw, right? And so if we look at 6.5 pounds of barley, 16 cents a pound, I think, or whatever we're at, and same with the straw, what we've got is $2.55 per head per day, but because it's shorter, we land somewhere in the middle. Now, I guess, the obvious part of this to me is that diet number one, with just a straight hay diet, even at 175 a ton, we have the ability to get consumption, but we've minimized the expensive stuff. We can minimize our grain intake a little bit, and we may need to come in, but the message of this is that, yeah, we're still at a cheaper diet that way. But if we had to, we might be able to save some time, even though it's a more expensive diet, and get cows at half a body condition score. What is that worth to you on the farm or on the ranch? I guess that's an individual decision. And again, this comes back to my first point about monitoring that body condition score. Some feeding considerations when we're using this stuff. We don't want to double dose free nitrogen or the urea because we can cause a toxicity. Secondly, if and when we need to apply water, we have to make sure it's evenly distributed. If it gets pocketed in different parts, if you tip bales up and you add water through a hose or you meter it in, I mean, first you have to make sure what your first dry matter level is at, then how much moisture do you need to add, and if it pockets up, you create hot spots. That may not be much of a deal if you're running it through a tub grinder, but you still have to worry about that. Now, point number 3, it does need to be covered. I know we've done silage pits where we don't cover them and we try and get ensiling and proper installation. Sometimes it just doesn't work. This stuff does need to be covered for proper treatment because it is a gas and it has to distribute evenly. It's good to have tub grinding for the windrow and feed bunk management. That does distribute this stuff out fairly well. And perhaps it is better used for cows and maybe for feeders. We want to restrict calving access to calves again because of this high level of urea and urea toxicity potential. Thought I'd throw a slide in there this morning just about what is non-protein nitrogen poisoning and urea toxicity. It's basically free nitrogen. It's not complicated or a bunch of Lego bricks. It's just free flowing. It is very rapidly digested. It is converted into excess ammonia in the GI tract, and we get you can probably pronounce that like I can. Hyperammonemia is the I think I butchered that, but anyways, that's the technical word. Basically, they get kind of crazy on this stuff. It's a big issue when you see these animals. The symptoms are tremors. They get very excitable. They're hard to handle. They'll start showing stomach pains, some frothy salivation, frequent urination, weakness in coordination, some bloat, some regurgitation. And if they really get hit with this stuff, based on the Merck manual as a reference, you would see death in 2 hours, sheep in 3 to 4 hours, and horses in 3 to 12. Bovine bonkers is what some folks used to call it back in the day. Basically, they get really nervous, really excited, and it's a very nervous looking excitable animal, and so they've gotten too much. So we want to avoid that as best as we can. Now, 2 considerations that I really want to stress and play home here is that we have to treat this stuff very, very carefully. And there's a lot of procedures in place. Anhydrous is mostly a crop fertilizer input, and we have adopted the use about 20, 30 years ago. It was researched good use in feedstuffs. But really, it is something that needs to be treated with a lot of respect. One of the reasons why we're seeing not that much anhydrous in the country is because of the safety and liability issues in using this. It's a very toxic gas. You do need to wear protective equipment to protect your eyes. You need to wear something to protect your breathing and skin. Anhydrous has a strong affinity for anything that's got water related to it, and our bodies are 70% of the stuff. So, anhydrous would find a great home through our eyes and if we inhale it into our lungs. So protection equipment is more than just goggles, our COVID masks, and rubber gloves. It's recommended by the people that do the training with this for the crop inputs that you need a full face respirator, a lot of protective gloves, and no skin is exposed. And you need to keep water close by to flush immediately. Again, they suggestion, don't smoke next to it. Don't combine feed supplements that have urea. So if you're feeding a beef supplement with 32, 30, or 20, and you have this, you may want to discontinue that just because that extra urea is free nitrogen and can push things over the top. Training and certification on the cropping side is there. The input providers, the folks that sell the stuff, there's a certification process in place. And, ensure equipment is inspected for leaks. Some of the equipment that was in place years ago, pulling it out of the iron pile to use again is probably not a good idea. So building new equipment, if you don't have it, or using equipment that's been tested is really important. And finally, when you're uncovering the feed, you do need to steer clear again because there are fumes and vapors to go with it. And so that is not only covering it and when you apply it, but also when you uncover the stacks, you do need to make sure that the wind is blowing in the right direction and you allow that to work itself out. Now, I'm throwing this up there because everybody's responsible at this point. The retailer, the person driving it for transportation, feeder livestock owner, all employees in the surrounding area. And if anyone's tried to uncover a silage pit, or you try and take a tarp off and you've got a bit of a wind, which we seem to have in Saskatchewan, you've got 3 or 4 people. And so that's just something to be aware of. And it's an occupational health and safety part. We don't tend to think of that much, but on farm, if you have employees or staff, and there's a crew of 6 people, you have to manage to make sure no one gets knocked with the gas, because once you've had a taste of it, it's not very much fun. So in summary, there's a whole list of things here, but the top 3 pros of this is that it is the one thing, anhydrous does have uses, and I think I've showed that. It will change your forage composition. The one thing that will improve a forage is anhydrous. You can improve the nutritional quality and you can increase the intake. So that's just a matter of how much you need it to do that. But the cons are there, and availability of the product is one. Dealers and distributors are reluctant because of the certification, and if you're not a long-term client, how do you prove you're able to safely manage this product? And safety is the big thing. It's a big concern. There's minimal forage energy improvements. I think I showed that earlier. And that means that you don't have the big jump in intake, the big improvement that we're looking for. And then there's also watching for hot spots. If feed toxicity can occur, it's treated bales that then where the anhydrous accumulates in one spot, one animal gets into it, and that's it. It's game over type of thing. So those are the pros and the cons, and then there's some of the rest of the stuff on there that you can read later or look to later. For resources on this, how to do it, you can find information on that, even just on our Saskatchewan.ca, search ammoniation, and you'll find a bunch of topics that are written, and we should hopefully manage the information you're looking for. And that's it for the anhydrous piece. I spent some time on that, but I think the takeaway is, if you can find this stuff, just be careful with it. It's a safety consideration, and there's some liability issues with that as well. It can work. I think in terms of the cost is something individuals will have to pencil out, but it can work if you can find the product and if you're set up to do it safely and appropriately. So that's the story that would be there. Okay. Now, the second topic was about molasses, and it's nice to just have 2 topics, but underneath molasses, there's 3 different areas to look at. And I think I'm going to focus mainly on the first 2, the liquids in the tanks, and then secondly, the pour-on. Those seem to be the biggest questions. I don't want to get into blocks and tubs, although there are some comments that I think I'll throw in here if I remember right. Why treat forages or use molasses? It can improve the utilization of low-quality forages again. It doesn't change the forages, but it can improve our use of it. It can improve the nutrient supply, our crude protein, minerals, and vitamins. If it's been adapted and it's got mineral packs involved, we can improve some things like the vitamin content and so on. It can be used to improve rumen microbe health. There are some sugars in there that can help microbes thrive a little bit better, and the protein content, if it's the right package, can boost the protein levels to keep them going. I think one of the biggest things is, when we're dealing with molasses on a straw or low quality forage, especially if it's a year old or been weathered, excuse me, you can decrease dust and improve palatability. I think there's some very good cases for using molasses to change the flavor and texture and palatability of a feed. It can help reduce some waste. So I think, you know, there are some very good pros to using molasses. And there's various options out there. You know, there's some dealers in Western Canada that have select products that they can get. And I mean, molasses is like, you know, it's definitely out there. It's not a new feed additive. You can find low and high protein options. Just to say that if it's a low protein type of supplement, it's most likely to be all plant-based with a little bit of nitrogen added urea. And then there's also the higher protein content supplements that have urea added to it. Specifications of molasses itself, it's about 60% dry matter, 40% moisture. Density is around 2.86 pounds per liter, and the price will vary again at 50 to 68 cents. And you know, some of this will depend on not just availability and market price is one thing, but the cost of bringing it to the operation, bringing it to the feed yard, and so on plays into a factor there. And as well as, are you renting equipment or do you have equipment, and are you having it injected or what format? Now, the TDN of molasses will be widely variable depending on the level of extras added in. I mean, if the more of a mineral pack is added in and so forth, you can see a TDN of 55. Raw molasses itself has a TDN of 75. I'll bring this up later, but I mean, oats themselves, I always do an oat comparison with molasses in my experience. You know, I say molasses is about a light oat equivalent. So that's my comparison, and I'll use that as an example later on. Threw this in just to show that, you know, primarily we're looking at molasses not so much as an energy supplement, but it's utilized as again a feed palatability deal and a protein additive. And crude protein on the liquid free choice, because it's free choice, we're not measuring or metering how much is being provided. 7.5% protein to 2.5, and then 32 and 29. So skip through that. Talking a bit about the molasses offered free choice, liquid form. You know, feed rate on the tags will tell you it's up to 1.4 pounds per head per day. You know, it is plant-based and it'll improve the protein. You still need to have some water, and I'm going to try and show you need minerals and grain additives with this as well. And so on this table, a 600-pound steer, let's say, you're feeding it and you've got a shortage of hay and you're keeping these animals. You want to get 2 pounds a day gain, and your first two diets are straw-based. Well, without molasses, if you try and get 2 pounds a day gain, you'd still have some grass hay. You'd have 6 pounds of regular barley straw. Here's your prices in the columns here a little bit. Barley grain again, 8 pounds of barley with 6 pounds of straw and 3 pounds of hay. That'll get us 2 pounds a day average daily gain at 9% protein, 64% energy at $1.80 per head per day. So we can do that. We need to add some minerals and some vitamins and so on. 50 to 53 days to 100 pounds of gain, and $95 for every 100 pounds of gain for that animal. So okay, great. Let's add some molasses to this as part of a free choice additive. We'll add our 1.4. You know, I struggled, to be honest, about keeping just the grain level consistent, but I wouldn't have any numbers to back that up. So I balanced the diet for 2 pounds a day gain. Same things across. Crude protein improved, you know, about 0.25%, or, you know, 0.5%, not even 0.5%. Your TDN stayed the same, but here you can see this little bit bump in protein and a little bit of a drop in TDN, and our average daily gain is estimated, again through cow bites, at about the, you know, a little bit better or the same. So you can take that extra protein to add to microbial output, and with a similar amount of TDN, and you can kind of get the same, but you're paying for that price. You're paying price per head per day of going up by 20 some cents a pound, or 12 cents or whatever that works out, 28 cents, yeah. So $1.04. That's if you have straws-based ration. Is it worth it to you to do that? Well, if you can minimize waste and you can gain that, maybe that's okay. You know, at the end of the day, it's costing a bit more to get there, but you know, can you buy, if you're short on barley, are you getting ahead much? Arguable, right? Now on grass hay, you could see a bit of a change here, where again, 7 pounds of hay, 3 pounds of straw, not much of a change in your grain. Molasses at 1.4, protein doesn't change, energy doesn't change, but you're adding more cost. So in the end, you might say, well, this is costing me a little bit more. And you might be right about that in terms of whether it's worth it to you. I would say that, based on this, if you had a straw-based diet and you didn't have much for hay, I think the point I'm trying to make is for same cost as what a grass hay diet would look like, you can feed, up to 6 pounds of straw, which is basically 1% of body weight, not pushing a lot of straw into these 600 pounders. But with a little bit of hay and a little bit more barley, we can get our costs here to be fairly comparable. Now, the one thing that the molasses might bring us in this case is that by adding it in, you're actually adding in some mineral and vitamin packages as well. And so consistency of health and intake on that level is good. What about just pouring now on the cow side and treating the bales themselves? And I borrowed a few slides from Barry Aremcio when he was with Alberta Agriculture. And I've used these slides before, so I'll go through them a bit. But liquid molasses, if you pour it onto straw, 70 to 100 pounds per bale, in this case, a 1,000-pound bale, will be a cost of $25 to $35 a bale at this time. A 1,400-pound cow will consume that 20 pounds, as shown before. So, when you do that treatment, based on that level of intake, that cow is eating 1.4 to 2 pounds of liquid molasses per animal. And the thing of it is we're not changing the fiber structure, so the intake can't change that much to begin with. And so based on the math that Barry provided, and I do trust this math, 20 pounds of straw, the protein is 4%. And by adding just that little bit of molasses at the 1.5 to 2 pounds, you can see we're jumping from 4% to almost 7% with not a big change in our TDN content. We still need some grain supplementation and potentially some calcium supplementation and phosphorus as well. But one of the other factors that goes with that is depending on the product base, you may see your salt level increase as well. Again, I punched together a couple of quick slides for that cow. Hay diet number 1, 28, we saw this before in the anhydrous slide. Again, a bit of a different take on this, but 214 days. Actually, I think I might have a different number on that. But anyways, in this example, we could do the math at $475 to gain 70 pounds. If you use a straw diet like the manuals showed, the recipes, 18.5 pounds of straw with some barley grain. I tried to get the intake to be very similar to get this 0.5 pound a day daily gain, a little bit less energy, a little bit less protein by sure. Again, there's our 290. If we were just to simply treat the straw with molasses at that 2 pounds and say, this is what we're doing, can we get our cow through it without feeding any grain? And no, we cannot. I mean, first of all, 22 pounds of total intake, when you do that a dry matter basis, it's only 1.3% of body weight dry matter intake. We're not really, we're feeding better protein, but our TDN is still fairly low. We're losing 70 pounds in a month. So we're going backwards on that. It's just really, really bad news for that cow. Finally, diet 4, if we add some barley grain in, this just proves the point that when you read the tag for molasses, it will say you need to still continue to add energy supplementation in the form of grain. You'll need some calcium, you need some phosphorus. So if we do that and we treat that bale, bring this up and add some grain in, our TDN content comes back up again. We've got more protein, a moderate time frame to gain 70 pounds. We're in the mix, and at 255 per head per day, it's 566. So in comparison, I mean, perhaps we are cheaper then to add molasses to these bales, doctor it up, get maybe our intake is a little better, we got less grain, we maximize these things out. Maybe if I maximize this, we'd be in a different spot, but this price would just actually climb up a little bit. So you can look at this, you can come to your own conclusions, you can disagree with it, but I think that, this is the kind of stuff that needs to be done when you look at whether or not to doctor these bales. I think the message is at the end of the day is molasses is not an energy supplement itself. It's more there for the protein. If we had to treat molasses like a light oat at 72 to 75% TDN, I think I demonstrated that applying 70 to 100 liters per bale, works out to 2 pounds per head. 20 pounds of straw and 2 pounds of oats doesn't get us very far if we consider that, right? We need 10 to 12 pounds of oats or 10 to 12 pounds of molasses to get us there, which is unpractical. it's expensive, and it's also unbalanced. If there's a mineral pack in there at if it's saying 2 pounds and we're feeding 5 times the level at 10, not only are we bringing in a $2.40 a head day just for the application alone, but we're also really cranking up our selenium and our copper and some of our other minerals. So the moral of that is stick to the feeding rate, and everything will be fine. The flip side to this, and following through on some of the information, is that when you actually add molasses to a bale, at the price that you spend at 20 bucks a bale, well, $20, depending on if you can find the stuff or not, I think this year is a good year to be thinking about molasses, because where feed grains can be found and purchased, or pellets for that matter, it's pretty easy to say $20 will purchase about 3 bushels of feed barley. That's costed out at $7 a bushel, right? So 3 bushels will buy you 126 pounds of lighter feed barley this year. Can you make that comparison? I think grain availability is probably the bigger factor to drive. And almost to the end here, but our calcium and phosphorus is going to need to be looked at very closely. They'll be low in calcium for sure. Barley straws at 0.13%, barley grains 0.06. Molasses doesn't contain a lot. The beef requirement, depending on production, whether it's a growing animal or just maintaining a beef cow, you need 0.27% to 0.5% calcium in the diet, and so you need to have something in place to top that up, whether it's limestone or a better mineral package. Again, formulate balance and consider where things are going to which animal that you're presenting this feed stuff to. You will need an extra energy source for sure. I hopefully demonstrated that. You just can't feed straw and molasses. You need to have something else, and you will need to supplement calcium and phosphorus. So plan for that. Top 3 pros: it does add protein for sure. I think it shows that you can really help with protein, which helps microbial capabilities in degrading these fibrous forages. It can add minerals and vitamins if you're putting in the right package, depending on the specifications. And I think the last one is that improving intake and reducing dust. That is a big bonus for sure. It does help with feed utilization and feed waste. So top 3, I guess you could make up some more different ones. The cons of it, there's practical limitations. A lot of cases they're saying for 2 pounds, 1.5 to 2 pounds. So we still have that as a limitation. It does not change forage composition like anhydrous does. Anhydrous has its own problems in terms of finding the product and whatnot, but that's one of the only products really available. There's a few other options, but we won't talk about that today. But it just doesn't change forage composition, and it won't replace an energy supplement. It's too costly, and it just isn't practical. So I think this is almost my last slide here, but in summary, for both the anhydrous and the molasses, and hopefully I was able to cover off those two fairly lengthy topics, diets will need balancing. Consider the cost of application in terms of labor, time, materials, and equipment. Safety considerations, whether you're spiking bales with molasses or anhydrous, people and the animals, worker safety, and then animal safety when it's being fed. And to begin with this year, I think we do need to consider testing feeds at a certified lab, just to make sure of what all we've got available. This is one of the first years where we've had such a widespread issue of feed quality. A feed test can save you money, I believe. So the checklist you have is know your feed nutrients, know what animal you're feeding them to, do treatments, change chemical and physical characteristics, and finally, you should be formulating with a nutritionist if you're uncertain of any of this stuff. A lot of practices that we know for certain. We just need a little help, I think, and some new things this year that we just have to address. So this is the end for the presentation, that is. And I just throw these things up just to try and lighten the rest of the mood. And with that, moderator, I think that's my last slide. You can find us at saskatchewan.ca, and the first base of touch for the province here is still the Acknowledge Center at the number shown on the screen. So moderator, I will hopefully not been too far over time, and I will end it there.
Thanks, Murray. That was great. Yeah, so this time we'll move into the question and answers. So if you do have questions, feel free to type them into the question or chat box in your control panel. If that has closed on your screen, there's an orange arrow that should bring it back into view. And like I said, if we don't have time for all the questions here today, we will follow up via phone or email or whatever works best for folks. So Maria, first question here, and I think you had kind of touched on it when you were talking about the ammoniation process, but are there any providers within the province that do this?
Yeah, you know what, I mean, so in a nutshell, I'd say there's limited access to the anhydrous right now. We originally hit this request up about a month and a bit ago now, and there was a survey sent out to some of the crop inputs companies that are out there, and there was a bit of a reluctance to go into selling anhydrous into feed treatment. And you know, there's some pressure on the anhydrous industry right now. I mean, it's because it's such a toxic chemical, environmentally sensitive, the gassing off, and again, employee safety and liability, I think, has been probably the biggest reason why I think there's limited availability. I'm not going to say that no one's going to be doing it this year, but I think there's some wariness by companies to sell this product. So I've been hearing that there's not a lot of anhydrous that is, there's anhydrous out there, but not a lot of it is, not a lot of companies are willing to sell it just because of the safety issue. It's just not the greatest stuff to work with. So there's that transfer of liability that I think is the big part. Plus they don't, I mean, the way the companies operate, they should be in, you know, part of what I understand anyways, is if they sell anhydrous for fertilizer, they have the ability to refuse service if they don't feel the equipment that it's being used with is, you know, is able to withstand the pressures because it's a pressurized system. Are there leaks? Are the joints in good shape? You know, I'm thinking about, you know, it's not hard. I mean, the recipe to do it isn't hard, to build some pipes and threads and ends and things like that. But how do you certify that, and how do you ensure that the operators are certified? So long-winded answer to saying I'm not sure if anybody that's really, it's not available. It's not like a PV Mart special in the flyer for sure. It's you know, I think it's available, but under the right circumstances, but not widespread for sure.
Okay, the next question very similar. How about molasses dealers throughout the province? So that would be those types of liquid type supplements.
Yeah, you know, I mean, we've got about 2 or 3 providers in the province, and you can find them. You know, there's you can get, you know, you can contact feed suppliers, feed companies. You can find molasses. This year, I'm told that you know, because beet molasses and that, I was thinking earlier on, like agronomically, our beet's going to be impacted by this drought that we're experiencing as well. You know, I'm told that it's not so bad because of the growing conditions for the beets weren't too bad, so we shouldn't be expecting any shortages. But there are suppliers out there that can do some supplying of the molasses. You know, the discussions I've had with some of them have been, you know, we can get it to you, we can transfer, we've got distributions in place for this sort of stuff, and it works out quite well. But then you know, do you need the equipment? Are you on a rotation, and is feed delivery again, and then the cost of transportation as well. So, you know, previous years it might be, you know, if you had an 8-hour drive to get liquid molasses to your place, it may not have been worth it. But this year, you know, are you, you know, as a distributor, and are you in that place to pay that cost to get it there, and just a few other considerations. But yeah, there's about 2 or 3 different distributors in, you know, in Western Canada for sure. So we have that list, I believe, on our feed listing service on our website. If not, we can make sure it's there. Sorry, I chewed up a lot of time on that answer.
No, that's perfect. And at this point in time, I don't see any other questions here, Murray. So I guess we'll take a moment. If anyone does have any final questions, feel free to type them into the question or chat box there. Otherwise, thank you so much for taking the time to join us for this webinar today, and a special thanks to you, Murray, for putting this presentation together. I did put the link to the survey into the chat box, so that should pop up for everyone there, hopefully. So please take a moment to fill that out, as it helps us plan future events. There's also the AKC number Murray has up on the screen, and the farm stress line was posted into the chat box as well. So feel free to call into either of those. And with that, again, thank you so much for your presentation, Murray. Thanks everyone for joining us, and have a great afternoon.
Thanks for having me.